this question, it is about mensuration. Mensuration is a typical problem that will appear in session A2. So I suggest you all to draw a figure so that you can know how to do the mensuration questions and think of the object more graphically. Object. Okay, so let's see. First information, you are given that a right circular cylinder container has a base radius of 16 cm and 14 cm, and it is held vertically, and some water are added into it. Okay, so you can draw it out. A circular cylinder should be like this, right? With base radius of 16. Oh, sorry, I'm not drawing in scale, but actually it doesn't matter because in the real exam, you just only need to know the numbers. Okay, so the base radius is 16 and the height is 14. Okay, and then a solid metal sphere. This is the second information. The solid metal sphere of surface area 144 pi cm square is put into the container. Okay, but you don't know some information about this sphere, but you know the surface area. So what is the surface area of the sphere? The surface area of the sphere is actually 4 pi r square, right? Surface area of sphere equals to 4 pi r square equals to 144 pi, right? So r square equals to 144 divided by 4, which should be 36. And r should be 6, or r equals to negative 6, which should be rejected. So we know the radius of the sphere is 6 cm, right? Okay, so part A, find the volume of the solid metal sphere. Okay, so after you know the radius, then you can find the volume, right? So the volume of sphere, do you remember the volume of sphere should be 4 over 3 pi r cube, right? 4 over 3 pi r, which is 6 cube, equals to cube times this one, which should be equal to 288 pi cm what cube, because this time is volume. Okay, remember the units are very important. Volume will be cm or m cube. Okay, and for the area should be cm square or m square. Okay, so this is for part A. And part B, find the original depth of water in the container. Okay, so we know that let's look at this information. Okay, it is found that the metal sphere is totally immersed into the water, and the water surface just reaches the top of the container, which means that if I put this sphere into the container, then the water just fit the top of the container. Okay, so the original depth, we will take this sphere away so that we can calculate the original depth, right? Okay, so volume of water plus volume of sphere equals to the volume of container. This is the relationship, right? So volume of water, we don't know, right? But we know the volume of sphere is 288 pi equals the volume of container. How do you calculate the volume of a cylinder? Which should be pi r square h. Pi r square h, right? So volume of water will be basically equal to 16 squared times 14, which will be 3,584 pi minus 288 pi. So the volume of water is equal to 3,296 pi cm cube. Okay, and then so we now know the volume of water should be somewhere like here 3,296 pi, right? And then we can calculate let h be the original depth of water. All right, so pi r square h equals to the volume of water, which would be 3,296 pi, right? So what is H? 3,296 divided by 16 square, which should be which should be equal to 12.875 cm. Therefore, the original depth of water is 12.875 cm. Okay, so we finished part A and we finished part B. And for part C, you are going to have a new set of information about a right circular conical vessel with curved area of 720 pi cm square is formed by a paper sector of arc length of 48 cm. So do you remember, a cone is like this. Its curved surface area is basically a sector, so that when you fold it, you can fold into a cone, right? So when you fold it, this arc length is actually equals to the perimeter of the base circle, right? And it is given by the question as 48 pi. All right. So if this is 48 pi, then let base radius of the conical vessel be r, right? Okay, so let's see. 2 pi r equals to 48 pi, r will be equal to 24. So the base radius of the cone here is actually 24. Okay? Okay, then we know the base radius is equal to 24. Then we can actually know that pi rl, okay? Pi rl, you can obtain the area because it is the concept that pi radius, do you remember? Pi rl is equal to the curved surface area. Okay, so where L, you can let L be the slant height. This is the slant height. Okay, so pi r L, where R is now 24, right? Pi 24 L equals to curved surface area given by the question is 720 pi. So L will be equal to 30 cm. Okay, so the slant height is 30 cm. So after we know the slant height is 30 cm, then we can know the height of the cone. Height of the cone equals to root using Pythagoras theorem minus 24 square equals to basically is equal to 18 cm. Okay, so this is 18. All right, so you now have basically the information. Oh, and also remember, it is an inverted right circular cone, so it should be inverted like this. Okay, okay. So then we can, after we know the height, we can know the volume, means the capacity of the conical vessel is equal to remember the volume of cone 1/3 times pi r square h, the height, which should be equal to 3,456 pi cm cube, right? Okay, then let's see. Then the vessel is held vertically, and the water in the circular conical cylindrical container is now poured in the vessel. Will the water overflow? All right. So now how much water do we have? The volume of water is here, 3,296 pi. How about the volume of the conical vessel? 3,456 pi. So obviously, if you pour into the conical vessel, it will not overflow because the volume of the conical vessel is larger than the volume of water. So we need to do a comparison because volume of conical vessel, conical container, the volume of conical vessel, which is 3,456 pi cm cube, is larger than the volume of water, which is 3296 pi cm cube. You need to do a comparison, or else you cannot reach a conclusion. Therefore, you can say that the water will not overflow. Okay, this will be the solution for question 14.